Hey everyone. So today I want to look at graphing. I want to think about graphing. I know it's been 2 days, so we need to do some more graphing. How about for bell work, we say, please find the domain and graph using transformations each. A, y equals square root of 4 minus x, and b, y equals negative 2, x plus 1 to the third plus 4. Okay? Just because we talked about those before doesn't mean you don't need to still know how to do them. Um, so, domain and graphs. Take some time to try and determine the domain of each of these and to graph each of these. In fact, you may want to graph and then determine the domain. Okay? All right. Come back when you have questions or come back when you're ready to check your answer. All right. So this, by the way, is the same as negative x plus 4. Okay, that's the commutative property of addition that your middle school math teacher tried desperately to get you to see, and you kept saying, well, a plus b, of course that equals b plus a. And yeah, the reason they were telling you it then, even though you thought it was obvious, is so you could see it and do it now, okay? Because this is hard to graph with transformations, but here I see two x transformations. I need to subtract 4 from the x's and then divide the x's by negative 1. So I'll start off with my reference points. I'm going to subtract 4 from those x's first, because inside is opposite land. So I'm going to have negative 4, 0, negative 3, 1, 0, 2. Okay? And I still need to come back and divide all my x's by negative 1. And so the final points that I'm going to graph are 4, 0, 3, 1, 0, 2. And therefore my graph of this, 4, 0, 3, 1, and 0, 2. Okay, so there's the graph of the first one. Remember, you need to label the points on the graph, not merely have them nearby. Now, what about the domain for this function? Well, when I look at the graph, I can see that all these x values work because they would all make y values. And this x value works, but there's nothing over here. So, negative infinity to 4 with a bracket. Remember, you could also do this domain the way we did 2 videos ago, where we set the stuff under the radical, the radicand, greater than or equal to 0, and we get 4 is greater than or equal to x, or if we read it this backwards direction, x is less than or equal to 4. If x is less than or equal to 4, it's these values over here, which is why this is my domain. Okay? So there's the first one. What about the second one? Well, in the second one, the domain is really easy because this is an x to the third, and we said all polynomial functions have an unrestricted domain. So I already know the domain here is negative infinity to infinity. All right, now what about graphing? Well, I'm going to start with those reference points. Negative 1, negative 1, 0, 0, 1, 1. And I'm going to apply my transformations. I see 2 y transformations outside of the function and 1 x transformation inside the function. So I need to subtract 1 from all the x's. And what was the rule when we had 2 y transformations? Do I add 4 and multiply by -2? Do I multiply by -2 and then add 4? It's PEMDAS, multiply, then add. So I'm going to multiply by -2 all the y values, and that will give me these intermediate points, -2, 2, -1, 0, 0, -2. And I still have to come back and add 4 to all the y's. So we've got -2, 6, -1, 4, 0, 2. Remember, we still need the characteristic shape of x to the third. Don't be drawing this. That's cube root of x. I need x to the third. So where are my points? Better yet. -1, 4, -2, 6, and over here I have 0, 2. So there's my graph. Okie doke. Don't forget that stuff. Wow, when we have our first test over this stuff, you need to know it. And you need to be able to do this transformation graphing literally all year. And if you're taking calculus, next year as well. So please make sure you're comfortable with your transformation graphing. Please make sure you're comfortable with interval notation. And to help you practice your graphing skills, today we're going to be talking about piecewise functions. So they are functions, so they'll all pass the vertical line test, but they come in a couple of pieces. So here's an example. F of x equals -x plus 1 for x is less than 0, -x minus 1 squared plus 4 for x is greater than or equal to 0. See, it comes in pieces. Now, we know stuff about these pieces, and let's see how to read this notation. We know that this is a line, a linear equation with negative slope and a positive 1 y-intercept. So my graph looks like that negative sloped line for x values less than 0. For x values greater than or equal to 0, it looks like this parabola that's flipped upside down, shifted right 1, and up 4. Okay? Now, I don't recommend that you use your transformations that way to graph these, because often what happens is you graph too much of this and too much of this, and suddenly you make a picture that looks like this. There's -x plus 1. And my parabola, here, my parabola looks like this with 1, 4. That's not a function anymore, right? That fails the vertical line test. Someone has done too much here. It only looks like this line for x values less than 0. See these x values here? X values less than 0, it looks like this line. So after that line, after x equals 0, we don't get any more of that. Now, what about the parabola? Yeah, I like the downward parabola, except it's only the down-pointing parabola for x values greater than or equal to 0. So this over here, no, it's got to go away. So that's where I am right now. Now, at x equals 0, because this says could be equal to 0, I have a point on the down-pointing parabola. So I've got that point there, 0, 3. But what about this? This is not included, this. So I want an open circle there, because there's no equal sign there. I go up 2, but I do not include 0. So that's what my graph is going to look like. And I, of course, want to plot some points on each of these. Now, I think it was pretty easy for me to do this because I've done this a lot, and I was thinking about what these looked like and what the transformations did. And so I want to give you a slightly different approach to doing this problem yourself. here's what I want to suggest. I want to suggest that you make a t-chart for each piece. We've got two pieces, we make two t-charts. One of them is negative x plus 1. And the other one is negative x minus 1 squared plus 4. Okay? For this one, I'm plugging in x values that are greater than or equal to 0. For this one, I'm plugging in values less than 0. Okay, pay attention, look and see what I'm about to do. Stop writing things, just look. Why did I put 0 on that one? Mr. Gupta, it says x value is less than 0. Well, I'll show you why in a minute. Suffice to say that what I want is to include this break point where the two pieces separate on both t-charts. Equals 0, closed circle for this 0. Not equal to goes up to but doesn't include 0, so open circle on that one. And then I'm going to fill in these t-charts, and I plug in a 0 here and I get 1, and I plug in a negative 1 here and I get 2, and I plug in a negative 2 here and I get 3. And over here, I plug in a 0, and I'm going to have 3. I plug in a 1, 1 minus 1 is 0, 0 squared is 0, plus 4 is 4. And if I plug in a 2, I end up with 3 again. Okay? So now let's plot these things. Okay, so 0, 3 with a closed circle. 1, 4 1, 4, and then 2, 3. Now, I know this is a down-pointing parabola, and I see the vertex there. There's my down-pointing parabola. Do not extend it over here. This piece, this downward parabola, only for x values greater than or equal to 0. Okay, not here. Now, what about this? Well, 0, 1, but with an open circle. Negative 1, 2, and negative 2, 3. I need you to label the points on the graphs. You don't need to label the hole. Okay, so this piecewise function, it's a function, it passes the vertical line test, has a jump discontinuity in it. These two pieces don't connect. Sometimes the pieces connect, sometimes the pieces don't connect. I don't know if the pieces are going to connect or not until I plug that break point into each piece and see if I get the same number or not. I got different numbers, so they don't connect. Okay? Please put the break point on each t-chart. Please put the break point on each t-chart. Okay, so that's what graphing piecewise functions looks like. I think we should practice a little more together before you go off to do your homework. So let's try this one. F of x equals square root there it is, square root of x minus 1 plus 1 for x values greater than 1, and negative 2x plus 3 for x values less than or equal to 1. Okay, so, I want to make those two t-charts. I want 1 to show up on both of those t-charts. Oh, I didn't show you with the last one what happens when you don't include that point. I'll do it this time. Okay, so two pieces. This piece, square root of x minus 1 plus 1, and this piece, negative 2x plus 3. For x values less than or equal to 1, so 1, 0, negative 1. And here, I want x values that are bigger than 1, but yes, I'm plugging 1 in here with an open circle. Okay? 2 and 5. Why didn't I use 3? Why did I use 5? Because when I have to plug a 5 in here, 5 minus 1 is 4, and I know that the square root of 4 is 2. If I plugged in a 3 here, 3 minus 1 is 2, the square root of 2, I'm a little uncomfortable graphing that. So this is a 2, this is a 1, and nope, sorry, plus 1 I forgot. So 5 minus 1 is 4, square root of 4 is 2, 2 plus 1 is 3. I plug in a 2, 2 minus 1 is 1, square root of 1 is 1, plus 1 is 2. I plug in a 1. 1 minus 1 is 0, square root of 0 is 0, plus 1 is 1. Okay, and now this piece. So with this piece, I'm going to be plugging in values of x that are less than or equal to 1. And when I plug in a 1, negative 2 plus 3 is positive 1. See how these are the same? That means that this open circle gets filled in with this closed circle. Okay? If I plug in a 0, I get 3. And if I plug in a negative 1, I get 5. So let's graph this. We've got 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, negative 1, 1, 5, 2, 3, 4, 5. Okay, 5, 3, right here on the edge, and 2, 2, and 1, 1, with an open circle. Now I know that this piece is the square root graph. So I want to see the square root shape here. Square root shifted right 1 and up 1, right? Don't draw a linear equation. You know, it's not a line through those points. It's this curve. It's this square root of x curve here. Okay, and then we'll do this other piece. Negative 1, 5. 0, 3. And 1, 1. 1, 1 is here. So 1, 1 fills in that hole. And this is a linear equation. Okay, it shouldn't be curvy. It's a straight line with a constant slope of negative 2. So let's see that. Okay, and now I want to talk about what happens with those students who say x value is bigger than 1. They don't put this on their graph. So what happens on their graph is they do that. And that's a problem because the function does exist from 1 to 2. So if you say x is bigger than 1, don't start with 2, or else you're going to throw away this part of the graph. Stop it. You want to start with an open circle at 1. Okay? What that tells me is put it on the chart, but have it be an open circle. Sometimes that open circle is filled in, like it is in this graph, this piecewise function, but the last one we graphed, there was no connecting the two pieces. Okay? All right. So, how about you do this one? F of x equals negative x plus 1. Oops, that was the first problem. I meant to give you square root of 1 minus x minus 2 for x is less than 1, and x minus 3 for x is greater than or equal to 1. Okay? So, give that a try. Graph that, please. Remember to label the points on the graphs. I'd make two different t-charts, one for each piece. And remember, when you go to graph the pieces, once you have the points, this has got to look like a radical, and this has got to look like a line with a positive slope. Okay? Think about your transformations. By the way, no, never mind. Okay, so off you go. Give it a try. Really, you should. because then it'll be in your notes, and you want stuff like this in your notes, and the extra practice will help you so that by the time you do the homework, you won't have forgotten all of this. Okay, so I'm going to make two t-charts, one of them for square root of 1 minus x minus 2, and one of them for x minus 3. On the x minus 3, I want x values that are greater than or equal to 1. And because this is equal to, I want the closed circle. Here I want values that are less than 1, but I'm going to include 1 on that table, and then some values that are less than 1. Here with an open circle, because this is not equal to, but I want it included on my list. Okay, if I plug negative 1 in here, if I plug 1 in here, square root of 1 minus 1 is 0, square root of 0 is 0, minus 2 is negative 2. If I plug in a 0 here, I get square root of 1 is 1, minus 2 is negative 1. If I plug in a negative 1 here, I'm going to have minus a minus. So 1 plus 1 is 2. You know, I'm not really comfortable graphing square root of negative 2. Well, I mean, I am, but you might not be. So why don't I use something here that has a nice perfect root, like negative 3. 1 minus a minus 3 is 1 plus 3 or 4. Square root of 4 is 2. 2 minus 2 is 0. So my graph is going to look like this square root function passing through these points. Let's sketch that. So we've got 1, negative 2 with an open circle. And we have 0, negative 1. And we have 3, negative 3, 0. And our square root shape there. Why does it point this way? Because it's got a minus x in front of it, and that minus flipped all of the x values. Now, what about this piece? Well, if I plug in a 1, I get negative 2. If I plug in a 2, I get negative 1. If I plug in a 3, I get 0. So 1, negative 2, oh look, they're the same. So these pieces will connect. And then 2, negative 1, and 3, 0. Remember, this is a linear equation. It needs to look like a straight line. Don't make it curvy and wiggly, okay? All right. So, how about a function with 3 pieces to it? Like 3x minus 1 squared plus 5 for x's less than 0, and negative 5x plus 8 for x's between 0 and 2, and 2x minus 3 squared minus 4 for x values greater than 2. Okay? All right, so 3 pieces means 3 t-charts. So the first piece, x value is less than 0, but I'm putting 0 on it with an open circle, negative 1, negative 2. And this piece starts at 0 with a closed circle and goes to 2 with a closed circle. And this last piece, x value is greater than 2, but yes, I'm going to put 2 on it, 3 and 4, but the 2 is going to have an open circle. Okay, so let's check these values. If I plug in a 0 here, I get 8. If I plug in a negative 1 here, negative 1 plus 1 is 0. 0 squared is 0, times 3 is 0, plus 5 is 5. And if I plug in a negative 2, I end up with 8 again. Okay, that's the left piece. What about the middle piece, this negative slope linear equation? If I plug in a 0, I get 8. Oh, look, they're the same, so this will fill in that hole. If I plug in a 1, I get positive 3. And if I plug in a 2, I have negative 2, right? Because 2 times negative 5 is negative 10, plus 8 is negative 2. And then finally, our third piece is going to have us plugging in a negative 2. Positive 2. Positive 2 minus 3 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. 2 minus 4 is negative 2. Oh, so this fills in that hole. All the pieces connect here. If I plug in a 3, 3 minus 3 is 0. 0 minus 4 is negative 4. And if I plug in a 4, I get negative 2 again. Okay, remember, looks like an up-pointing parabola, looks like an up-pointing parabola, looks like a line with a negative slope. Think about those things when you graph this, okay? So, I've got 1, 2, 3, 4, 5, 6, 7, 8, 0, 8. I've got negative 1, negative 1, 5, and negative 2, 8. And it looks like an up-pointing parabola. Okay? Now what about from 0 to 2? From 0 to 2, I'm using these values. That open circle here gets filled in with this closed circle value. 1, 3, and 2, negative 2. There's the middle piece, and now finally our last piece. We're going to go through this open circle gets filled in with red's closed circle. Hey, look, don't do this. I don't know who taught you that, but don't do that. Because when you write that, I think you don't know what's happening at that point. There's an open circle, and if the closed circle fills it in, then it's no longer an open circle. So don't draw an open circle, right? Don't give me that. That gets marked wrong. Okay, so what do we have? We have 2, negative 2. We have 3, negative 4. And we have 4, negative 2. We know this is an up-pointing parabola through those points. Okie doke. All right. Hey, what if instead of negative 5x plus 8 here, we had a different piece? What if we had the piece 4? Okay, well, when I go to make my t-chart, I'm going from 0 to 1 to 2. And both of them have closed circles. Okay, that was an open circle there and an open circle there. Okay, so now what does the graph look like? Well, this is still an open circle. And this says 4. No matter what x value you want to try and plug in, there's no place for it. This is just going to petulantly say 4, 4, 4. So 0, 4, 1, 4, 2, 4. What kind of graph is that? Oh, that's the linear equation. Right. Y equals 4 is a horizontal line. So when I see just a number here, I'm graphing a horizontal line. Notice, though, this open circle doesn't get filled in, and this open circle down here also doesn't get filled in, because I've got closed circles here at 0, 4 and at 2, 4. Okay? So that might show up in your work as well. Okay, the last thing I want to look at with you before you head over to the homework are some word problems. Word problems. Now, the word problems we're going to see here are going to be piecewise functions. Okay, first word problem. Your cell phone plan costs $75 a month and gives you unlimited talk and 500 text messages per month. Okay, and no data. Sad face, no data. Okay, After 500 texts, it costs you 10 cents per text. Okay, so now it says here, write and graph a piecewise function that represents your phone bill as a function of the number of texts. So I want a phone bill as a number of texts. And I see for the first 500 texts, so when t is between 0 and 500, I have to pay $75 a month plus nothing, right? I'm just paying that $75. But as soon as I make more than 500 texts, I've got to spend 10 cents after that. So let's think about linear word problems. A rate of change, dollars per month, that's a rate of change. A rate of change times a variable plus the initial amount. Whoa, that's a plus sign. Per text, sorry, not per month. We're doing this as a function of texts, not a function of months. Okay, sorry about that. That's not a t, that's a plus sign. Okay, so rate of change times the variable, 0.10 t, plus the initial amount. There we go. And what's this good for? This is good for t greater than 500. So we have here a horizontal line up to 500, 500, 75, 0, 75. And then, for anything above 500, we have this linear equation with a positive slope. Now, I have one point on that line. How about another one? 501 texts. Oh, but I'm only paying for the ones that are bigger than 500. It costs you 10 cents per text you sent after 500. So I need to do this. T minus 500. Why did I know to do that? Well, I'm not paying the additional 10 cents on the first 500 texts, just the ones bigger than 500, bigger than 500. So I need to be able to plug a number in here and not be paying for those first 500. So if I plug in a 501 minus 500, I only have one text to pay for. So 501, comma, 75.10. And if I make two texts, 502 texts, 502 minus 500 is 2. 2 times 0.1, that'll give me this point over here, 502, comma, 75.20. Okay. So there's my piecewise function and my graph of it. Shall we try one more? No, you want to hide. Yeah, come on, we can do this. They're just linear things or constant things. Your favorite dog groomer charges according to your dog's weight. If your dog is 15 pounds and under, if W is between 0 and 15, then they charge you $35. If your dog is between 15 and 40 pounds, then they charge you $40. And if your dog weighs more than 40 pounds, then they're going to charge you $40 plus, what's our rate of change? $2 for each pound. Now that's pounds over 40, so I want W minus 40 here. Okay, those are my three pieces. So let's think about the graph here. It's the constant 35 from 0 to 15. then we jump up to 40 from 15 to 40 pounds. Both of these are, that's an open circle at 15 and a closed circle at 40 with $40 grooming. And then over here, once I get past 40, I've got negative 2W minus 80 plus 40 is minus 40. And that's positive 2W. Okay, so if I plug in 41, 41 times 2 is 82, minus 40 is 41. So that's going to be here, 41, 41. Okay, we could even plug in a point like 50. 50 times 2 is 100, minus 40 is 60. So if your dog weighs 50 pounds, they're charging you 60 bucks. There's my piecewise function. I had to build the piecewise function first and then graph it. Now, if you're not comfortable graphing these horizontal segments or graphing any of these things, remember you can always use a t-chart. So at 0, we've got 35. At 10, we've got 35. At 15, we've got 35. Always 35, which is why I graphed that horizontal segment. Okay? All right. I think you might be ready to try the homework worksheet. We have a homework worksheet tonight, graphing piecewise worksheet. And here it says graph piecewise partner worksheet. Graph piecewise partner worksheet. You know, I just want to take a quick look at that partner worksheet to see if we just did anything from it. I might have just done some of those problems, so that wouldn't be a good thing for you to try and do, because we've already done it. Okay, pre-cal, graphing basics, partner assignment. Oh yeah, we did some of these problems already. So no, you don't have to worry about 10 in-class worksheet. You can just skip over that because we just did some of those problems. Instead, just do, so don't do this one, do this one. Graphing piecewise worksheet, not the partner one, the regular one. This will say assignment 10 homework, okay? All right, well, we're almost at our first big 50-point quiz. We just have one more review lesson to do. And so let's see how things go. All right, take care, everyone.